This is what I need to do all the time.
Now let's live into the future.
This is where it goes off the rails again.
Yeah, and think a little bit about what's on the horizon. And maybe it's just worth saying, confining more of this talk to the science of ENSO as opposed to the prediction. And maybe the prediction is as we discussed in the last time, when we sort of alluded to it, it was less convincing then than it is now that an El Niño will take shape. Although I don't think the story has changed from the end of the monsoon season in September. There was still, the idea then was a sort of a weak, maybe moderate El Niño event. We're still in an El Niño watch. It's most likely going to evolve to a weakish event, hovering around that sort of definition. So yeah, what's your take on the prediction on ENSO right now, Mike? Not on the science.
Okay.
What else is there to say about ENSO?
It's like Groundhog Day. I feel like we've had this discussion in November before. I mean, it's because we have had this discussion in November before. The seasonality of ENSO development is development over the summer and typically peaks December, January, right? So we're in between. And we typically are looking at sea surface temperature pattern. We're looking at primarily sea surface temperature pattern, subsurface temperatures, to give us some indication of where an El Niño event might go. Mm-hmm. And right now, we have the pieces where we see the sea surface temperature pattern, as I think you noted, that we see the warming in the part of the Pacific that you'd expect to see with a maturing El Niño event, but we don't see the atmosphere responding yet. And it's kind of a mixed bag when you look at across the agencies of who's calling what. Ben noted to us that the Japanese Meteorological Agency is called it.
Called it an El Niño.
Called an El Niño. I think the Australians have not, right?
I don't think NOAA has either.
NOAA is still in watch, as you noted.
Yep.
So we're in this weird kind of wait and see. And so I think...
And the coupling is important because it reinforces...
There's no point in us worrying about El Niño if it doesn't couple, right?
And that's because the coupling is with the atmosphere.
Absolutely, yeah.
And it's the atmosphere that brings our... Yeah.
The teleconnection does not exist if the coupling doesn't occur. Okay. Right. And the teleconnection is that when we have an El Niño event, we see an adjustment in the jet stream that typically moves the whole jet stream and strengthens to the east across the Pacific Ocean and strengthens the subtropical jet, which can enhance our southern storm track and give us more moisture than we would expect to see during say a La Nina winter, where the storm track is more northerly displaced. So this idea that the coupling hasn't occurred yet is not catastrophic. It would be better if it had by this point in time. It would give us a little bit more confidence that we would see a sustained event. Could it couple soon? Absolutely. Could couple in 2 weeks and we could see it sort of play out. Could it not? Yes. It could also fizzle out. There seems to be some evidence, though, in the short term that there's warm water in the subsurface that we expect to see come to the surface, and the word is shoal.
Shoal.
I was set you up.
I wasn't listening.
I know you weren't. I could tell. Shoal. The warm water will shoal.
Well, you go on these monologues, and
I do.
I start doing other work,
and then I get bored, and then I'm looking around, going, "Am I still talking?"
I was listening. I just didn't know what you wanted me to say.
Totally true. Yeah, I think I could have wrapped it up like.
No, it was great.
Three sentences
I learn every time I do these podcasts.
I kind of see the same thing over and over again. So,
I have a love-hate relationship, I think, with ENSO, as maybe many climate scientists do.
I do too. I don't know if you've noticed my angst in just this whole concept.
And so here's the love. When you look at the correlations between the things that are impactful here in the Southwest, let's just say precipitation. There's also higher correlations with temperature, but in terms of precipitation, it's the climate phenomenon that you can point to at sort of a seasonal scale that has the highest correlations, right? So there's something there.
Yeah.
And it's usually in the winter.
Yep.
It's actually, I think, only
almost
in the winter.
Always in the winter, yeah.
So that's the love, because, without it, you're just a meteorologist. Sorry. No, that was not a criticism. That was a compliment. I'm talking about.
Ouch.
But the hate is that, those correlations, as you said before, are 0.5. So they're explaining, 25% of the variance. So in a sense, You're crinkling your brow, which makes me feel like I'm saying something
No,
wrong.
I just had pulled up one of my plots because I was like 0.5, and then I looked at one of our stronger correlating, and I actually have 0.4.
Oh,
so
right.
I think it went down with some more data points.
Right, and those correlations matter. The strength of those matter to where you are in what month. So that it's not treating the Southwest as this monolithic thing. So 75% of the variance then is open to all of these other things. I think on the one hand, if you think about this with like a card game, a poker example, right? If I know one or two of your cards in 5-card draw, like I feel pretty good about that.
Yep.
And so there's something there. I mean, if I had, I don't know, just extend this. If I had like 3 kings and I knew that you didn't have in one of your 2 cards or in both of your cards, they weren't aces, I feel pretty good that I'm going to win that card game.
Yeah.
Not to say that you can't have 3 aces.
Right. Well, it's shifting the odds, right? I mean, just knowing what you have to work with.
Right. And so then I guess this takes me to thinking about these correlations a little bit more. And usually the analysis, or maybe not usually, but much of the analysis just looks at a sort of simple treatment of the sea surface temperatures and relates it to precipitation. But as we've learned recently, the spatial pattern in the tropical Pacific Ocean matters a lot.
Yeah, and maybe even sort of backing up one step, let's just talk a little bit about, or just state, the fact that El Niño is a slowly varying phenomenon on the order of seasons to years is its strength. The fact that it is something that you can observe and you know that it will have some staying power, right, like over a period of months, and you know that it may then change the mean state or the average state of the ocean and then the overlying atmosphere, gives us that feel. It's like what it's your poker analogy.
Yeah,
there's information in it, right?
If it was moving quickly, it would be
weather.
Less useful. Yeah,
exactly. Right. And it's where we have other phenomenon like Madden-Julian oscillation, where we're leveraging it, but it's weather scale and it has some predictable patterns across the globe, and it will get into states and phases, and we're using that on the multi-week to month time scale to leverage, and it's imperfect as well. And so there aren't very many tools where, as you observe some part of the climate system moving in a direction, that you can anticipate where it may be in a couple of weeks or months, right? Mm-hmm. So it's those slowly evolving phenomena. So that's what ENSO is, right? But to your point, we got, I think, collectively pretty burned by the 2015-2016. I think we were anticipating a fairly canonical impact. Yeah.
Wet here in the Southwest.
Because we've seen other events of similar magnitude do the same thing, but it was small numbers.
Yeah, so just to put this in context, that 15-16 El Niño event was the strongest on record. And it outpaced the 97-98 event and the 82-83 event, which were the 2 other mega El Niños.
Absolutely. Nicely done. Right.
And those 2 years, 97-98, 82-83, generated much above average precipitation.
Yeah, so they were hanging out in a territory of strong events, so we expected that one to follow suit, and it did not. Okay.
We'll throw the statistical classes that we took out the window on that one.
Yeah, I mean, we knew small numbers are not, we had a linear correlation that we expected to follow with strength, but there had been some stuff in the literature that had suggested that the flavor of the El Niño mattered, and we kind of knew that, and it did look, though, as this thing was evolving, that it was going to be of the flavor that was similar to 97, 98, and 82, 83. But it didn't end up being that way.
Right. So the 2 things that I think have been most interesting from my perspective as I've read the recent papers and traced the evolution of ENSO thinking is, one, it's that the locus of convection in the tropical Pacific Ocean and related, the pattern of sea surface warming matters. It tugs the atmospheric strings in different ways. Uh-huh. And so you can't just treat ENSO as, you can't average over a particular area and put a number and then correlate that to something else, that there's actually nuance within that area. So that's one thing. The other thing that was really interesting to me was thinking about these events themselves are influenced by different processes that are acting across a spectrum of timescales. Yeah. So from these weather timescales, like these westerly wind events matter in kicking off and sustaining these events. And those those seemingly happen on weather timescales.
Absolutely. Yep.
And then there's much longer term processes such as and I know there's controversy around this, but there does seem to be some relationship with the Pacific Decadal Oscillation and some other climate phenomenon that at least descriptively are moving at much slower timescales, years to decades.
Yeah.
And anything in between.
Absolutely. Right. There's what they call internal stochastic variability. So it's like sort of weather noise forcing. And then there's this kind of analog of the ENSO system where we think of it as sort of charging up as a battery with all this warm water building up in the West Pacific, and then it has to discharge. And as it discharges, it can do this in a kind of a myriad of ways. And at some point, it will have to discharge. It can do it slowly, and it can do it kind of in a clumsy way through some of these sort of mid-Pacific and do it over a period of years and not necessarily have the teleconnections with it. Sometimes it can do it all at once, like it did with 97, 98 or 82, 83, where it just sends a big slug of water over there. There's much cooler water in the West Pacific. It's all in the East Pacific. Collapse of the trade winds, and then all that, the teleconnections emerge from that, and then the system actually has to build warm water back up in the West Pacific before you can even think about having another El Nino event, right? And so we've been more in this sort of slow, leaky battery kind of discharging over the last couple of years, even with the 2015, 2016 event, which is why I think we're leaning into seeing another event right now.
Another thing, so you sort of mentioned this, I think, unless I was hearing you talk in my but one of the difference between the 97, 98 and the 2015, 2016 was just where in the tropical Pacific that warm water was.
Super subtle too, because if you look at the maps, we were looking at the maps, 2015, 2016, slightly more central Pacific. 97, 98 was a hardcore Eastern Pacific event.
So warmer water.
Collapse of the trade winds, ceasing of upwelling on the South American coast for the most part. And as you talked about earlier, that where that warm water is going to draw the anomalous convection or the unusual convection further east along the equator. And so the further east you move that, the more it can lead to that subtropical teleconnection that we would see in the Southwest. If it's more out in the Central Pacific or even on the other side of the date line, we call it Central Pacific event, and its teleconnection then it absolutely does impact the jet stream. It just doesn't impact it in a way that's useful for us. Like remember 2015, 2016, we had that anomalous convection, but it was in the Central Pacific and it was influencing and enhancing the jet stream, but it was far enough west that there was a flick in the jet stream. So as those enhanced storms started to roll into the California coast, they were going over Northern California and into the Pacific Northwest. If we had moved that whole thing to the east, you would have seen that storm track drop south and then come over us.
Were the westerly wind events or wind bursts, they were more to the east in 97, 98. Is that right?
Yeah. I mean, looking at this paper that you and I were reviewing, there was a couple of big ones that really kicked it off. And then the westerly wind events themselves sort of followed the temperature gradient, which was emerging further east. And so you did see them occurring a little more frequently and further east with the 97, 98 event. Through 2014 and 2016, we had a mess of them, westerly wind events, which is why we were so excited. And we thought this thing was really going to kick
Remember,
in.
this was that double dip, right?
Like it was 2014. We did it in 2015. I don't even know if 2014, 2015 made the cut.
It wasn't, it might not have. I think
it was marginal if it was weak. But it was interesting. You saw warming across the whole Eastern Pacific, but the magnitude wasn't particularly great. You didn't see the anomalous convection. And then it did finally kick in, but not of the magnitude of the 97, 98. And so I don't think you saw the anomalous convection of the magnitude and of the duration that you'd wanted to, and it was displaced.
So what leads to these westerly wind events?
Well, sometimes they're typhoons in the far western Pacific. They can be off equatorial typhoons. They can be Madden-Julian oscillation type. They can be sort of
is there any
waves
prediction in them?
Yeah.
At the subseasonal level?
Well, it's weather time scale at that point. And at that point, it has to be, is it in the right spot at the right time to induce like a Kelvin wave of an oceanic Kelvin wave to that will progress to the east.
So then relating that to what's going on right now, it did look to me when I looked at the sea surface temperature maps that we're sort of more in the flavor of a Central Pacific El Nino than we are in East Pacific. And of course, we're at a weak level. So I'm not even sure it's that meaningful to talk about Central and East Pacific El Ninos in like a sort of borderline event.
Yeah. Looking at the Climate Prediction Center output as of late, some of the discussions, it's pretty lukewarm. As we talked about earlier, there's warm water coming up with a Kelvin wave coming across. So some of that warm water will shoal in the Eastern Pacific, which could help. Maybe it would change some of the spatial structure of it. I don't know. It still doesn't look like it'll be that East Pacific-y at this point. And the models certainly are leaning towards it being more of a Central Pacific event. I don't know. It could be real subtle.
Yeah.
There's a Madden-Julian oscillation right now that is constructively interfering with ENSO, which would suggest that it would help with some of the coupling, but I haven't seen that.
Interfering is the right word.
It's kind of weird.
Constructively
it's like,
interfering.
When you say like constructively interfering versus destructively interfering, I had to think about that.
Sorry, that's my mom's
No, it's good. And maybe I've even been
influence on me.
It's good. I read that and I went, is that a good thing or a bad thing? And I'm still not sure, but I think it's a good thing. But the discussion also noted too that if there is any coupling, it's past the date line to the west, which is way too far for it to happen. So, and this is where we're now at the weather time scale of El Nino to see if we can start to see some weather scale features enhance the coupling or start the coupling.
We have talked about in the past that strength does matter. I mean, this is one of the, in terms of its impact on precipitation, at least for California. I did some recent reading and there are very weak links, if significant at all, between a weak El Nino and a moderate El Nino and California precipitation, whereas there are stronger associations with a strong El Nino event. Right. That's probably similar to southern Arizona.
If you look across Arizona and we just organize the strength of ENSO versus seasonal precipitation, just say like maybe we take the core winter, the December, January, February. If I look at southeastern Arizona, so it's everything from Pima County across the southern counties up through Graham and Greenlee, the correlation between ENSO strength and seasonal precip is about 0.5, right? So 25% of the variance. And you see as you get further out in ENSO strength, precip totals typically go up, except for 2015, 2016. And La Niñas are fairly consistently drier than average. So the models are suggesting about a 1 degree sea surface temperature anomaly, which is weak, right. And if we look at past events at that threshold, they're not great. Like we have a couple of very dry years that are below the La Niña averages there. We've got maybe 1987 was almost kind of on the
high variability though.
That's exactly it. And I think that's the point of some of these analyses is that the spread increases as kind of in the middle, where you're away from the strength of that. If this thing strengthens, I mean, I kept thinking maybe a good analog would be 2009, 2010. We had an El Nino event come on late, and it strengthened quite quickly through December. Remember, we were working on the FEMA project. We talked about flooding events in Arizona, and that was a year where January ended up being record snowfall in Flagstaff, and we had up 10 inches of rain in Globe and that kind of stuff. But this is where we're at. I don't really know. I think your analogy is that we have some information. It's certainly not a La Niña, so I think that we can
say it's not a La Niña.
We can say it's not a La Niña. We can say it won't be a La Niña, which means that it's not, like a slam dunk for it being below average. But it doesn't mean below average isn't on the table for this particular winter. But it does suggest we have more opportunity on the wet side as well. so not useful. We're kind of dancing around. I think we're less excited about this because we got burned recently. This thing is leaning towards
It's also a weak
Pacific.
event.
It's a weak event. It's a Central Pacific. Oh. All of the characteristics of El Nino I like the least are all present this year.
Well, so
how's that for cheery?
Jeez.
I know.
All right.
You know what I'm rooting for? MJO. It's all MJO all winter. That's what MJO it.
Well, this is what happens when, we skip a month is we end up talking
like
for an hour and a half.
Pent up. Yeah. We have to do a holiday one though, with hot chocolate and candy canes next month.
Okay. All right. I
put it
like
on your calendar.
I got it. All right, Mike. Thanks again.
Thanks, Zach. Catch you next month.
Thanks, everybody.
Happy Thanksgiving.
Yeah, happy Thanksgiving.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, research, outreach, and assessment specialist with CLIMAS.
Holy moly, man. We were pent up. Dude, cancel your meeting. It's ridiculous.